So good morning, everyone, and welcome back. And for those joining for the first time today, I'm Patrick Amos, president of the Independent Telecommunications Pioneer Association, National Capital Chapter. Today, ITPA proudly hosts our first virtual event of the season. We're thrilled to have you with us today as a part of ITPA's ongoing and popular series of information exchange sessions, from in-person luncheons to now remote sessions as part of our monthly virtual series. Today's Autonomous Vehicles and Internet of Things webinar will have a panel focusing on Internet of Things ecosystem and evolving alongside in the efforts to deliver autonomous operated vehicles and the infrastructure support, with input from our guest panelists, Michael Sherwood, City of Las Vegas, Curator of Disruptive Innovation, Charles Swisher, Lumen Technologies, Smart Solution Practice Director, and Carl Anderson, Federal Highway Administration Technical Director, Operations of Research and Development. So ITPA, for those who don't know who we are, a little bit about ITPA is the Independent Telecommunications Pioneer Association is a nonprofit professional association created by and for the telecommunications industry. Dedicated to community service, ITPA has been serving the public on behalf of telecom companies since 1920. ITPA represents more than 9,000 telecommunications employees, retirees, and industry affiliates nationwide. A special thanks to all those that attend our annual awards banquet last month. It was a great event, and it was great seeing you all again. And we actually had a really great time. ITPA and who we support. Our charities are a little bit more about the local charitable causes that support ITPA. We are thrilled to announce that we are launching our inaugural STEM grant program to help those interested in pursuing a career in technology and additional support to ensure their success. For those who weren't able to join us at our annual awards banquet last month, I was delighted to be able to present on behalf of the ITPA 3 separate checks ahead of the holiday season to the USO, the Capital Area Food Bank, and JDRF Mid-Atlantic Chapter. We've received great feedback from our local charities, and specifically JDRF individually reached out to me directly again to thank us for all of our support and for everyone's continued effort. JDRF was happy to announce, with our assistance, they've developed multiple cell therapies which have gone on to clinical trial stage and approved research and helped create an influx of diabetes devices and the launch of JDRF's Tide Pool Loop Monitoring app. Thanks again for all your support. Next year, ITPA hosts an annual golf tournament to help support our 3 charities and always have a team of veterans on behalf of the SGMA as well. More on our annual golf tournament a little after today's event. And now, it is my honor to have been elected the 2022 ITPA president for this upcoming season. I'm thrilled to announce the following chapter additions. Ms. Swati Patel will be moving from chapter secretary to assuming the role of vice president. Ms. Mary Beth Jones will be assuming the position of treasurer. As president, I'm thrilled to be able to continue to work side by side with both of you, and thank you for your dedication and continued support of our chapter's growth. And speaking of growth, I know many of you may see some new and familiar faces. I am honored to welcome and announce the following newest board members and committee chairs. I am thrilled to welcome a distinguished member of GSA, Mr. Sam Navarro, who is joining our board of directors. Sam will help co-chair our speaker committee, and we could not be more excited to welcome him. I'd also like to welcome Ms. Donna Miller to our board of directors, who will also be working hand in hand with Sam, leading our speaker committee. On behalf of our sponsorship committee, I'd like to welcome our newest addition, Ms. Karen Fitzgibbon, and Miss Nancy Grand Prix. Please join me in welcoming our ITPA members of tomorrow, our 2022 protege, Megan Pilemeyer, Thomas Wood, Doherty. And of course, none of this would be possible without you, our sponsors of ITPA. I'd like to take a moment to personally recognize the contributions and support of all of our 2021 sponsors. Thank you again for all you have done to help make our annual golf tournament and our annual awards banquet a great success. We are grateful for your continued sponsorship support and thrilled to have an array of new sponsors for this season. And now I'd like to officially announce our new lineup for our 2022 season. Our platinum sponsors, Avaya Government Solutions, Comcast Government Services, Granite Government Solutions, Hughes Government and Defense Solutions, Lumen Technologies, and CommScope. Our gold sponsors, BT Federal, Crown Castle, MetTel, SUS Consulting, T-Mobile Secure Federal Operations, and Verizon. Our silver sponsors, Equinix, GES, Turning Point, Pathway Partners, and Zscaler. And our technology sponsor, Papnotes Intelligence. And now, before we begin, a quick few items before we get started. For our press, we welcome our friends and colleagues from the media. As a reminder, today's sessions are all on the record. Questions. You may submit all of your questions and our moderator will try to get through as many as possible. You will have the chat feature as well as the questions feature embedded in the Zoom platform. Any technical challenges? If you're having any technical difficulties, use our chat box in the toolbox and chat with the webinar host. And today's webinar recording will be available for your viewing on the ITPA NCC YouTube channel. If you would like a copy of the slide deck as well, reach out to us at info@itpancc.org. And now, without further ado, I'm pleased to introduce one of our newest board members and a personal friend of mine, Ms. Donna Miller. Donna has worked in the telecommunications and information technology industries for 20 years, gaining experience in collaboration technologies, cybersecurity, cloud edge technologies, and customer experience. As a seasoned business developer and senior director at Lumen Technologies public sector, she is passionate about helping large federal enterprises find answers to problems, effectively working to develop solutions. And now it is my honor to welcome Donna.
Hi, Pat. Thank you so much. And I'm very pleased to be part of this first ITPA luncheon, kicking off the 2022 series. Today, as mentioned, we'll be talking about AV. Now, back in the day, AV used to mean audiovisual, but today its meaning has evolved to represent autonomous vehicles. And we have a very impressive lineup of panelists today. First up, I'd like to introduce Carl Anderson. Carl is the Technical Director, Operations R&D at the Federal Highway Administration. His office conducts research on new and advanced technologies that support innovative ways of moving people and goods and the development of applications that use those technologies. We could not even begin to contemplate bringing this topic without someone from the Federal Highway Administration. Our second distinguished panel is Michael Lee Sherwood. Mike is the Chief Innovation Officer and also known as the Curator of Disruptive Innovation for the City of Las Vegas. Michael has real-world experience as the City of Las Vegas has made significant strides in implementing smart technologies for smart cities. He has more than 20 years of management experience, specifically in the field of technology, process improvement, and innovation, with the majority of that experience being in municipal government operations. Our third notable panelist is Chip Swisher. Chip is the director of the Smart Solution practice at Lumen Technologies. He has extensive knowledge of the technology market for those solutions and consults with customers on topics such as technology and vendor selection, solution architecture, and implementation roadmaps. Chip is joining us because the infrastructure supporting IoT is evolving alongside the effort to deliver autonomously operating vehicles, and therefore carriers of all sorts are part of this conversation. While we have, as Pat mentioned, formulated some questions for our guests already, certainly if you have some questions of your own, I encourage you to submit them in the Q&A section of this platform, and we will try to address them as we go. So welcome, panelists, and let's get down to some questions. My first question is kind of more for Chip, and that question is, where is autonomous vehicle technology today, and what needs to be considered from an infrastructure perspective or that of software or security?
Sure, absolutely. Thanks, Donna. Thanks for having me on the panel. So as we continue to evolve, as we look at autonomous vehicle technology, we look at it from a number of different angles. So you hear a lot of industry terms around vehicle to vehicle or V2V, and vehicle to infrastructure, or vehicle to the environment. You hear a lot of V2I or V2X technologies. Obviously, as we look at the technology inside of the vehicles and how they interact with the other vehicles around them, the technology is not new. I talk a lot about, I had a car that was a 2008, 2009 car that, I think has probably 80 or 90% of the technology that you needed in order to be able to do that, right? Your ability to detect lanes, to be able to detect distance between other cars, et cetera. So as the technology continues to evolve, really the industry has been focusing on, really the last 5% and really in the last couple of years on the last 1%, and really trying to get all of those, we'll say, unique scenarios and things that don't necessarily come natural to the vehicle or to some of the other programming to really be able to handle that. So, construction in the road, things in the road that, aren't necessarily part of what the vehicle would tend to expect to see. So when we look at, though, the some of the continued innovations, really we see a continual increase in really the vehicle to infrastructure. And so if you look at the technology that the different DOTs, whether it be the US DOT or the state or local DOTs have been working on, really comes into this classification of what we call roadside units. And those are technologies that allow the vehicles to understand what's going on, situationally aware around them. And a lot of those technologies today are really one way. So if you think of, say, a traffic signal, a sensor at a traffic signal now, being able to communicate directly to a car to say, hey, here's my current status. I'm red, I'm yellow, I'm green, and here's what I'm going to change status. A lot of those communications are one way. But as we continue to see the evolution of those technologies, we're going to see them, be much more two-way and two-way interactive between the vehicles and those roadside units. And that's really where, from a telecommunications and a technology standpoint, we're going to see a continued acceleration in the networking demands, in and around the cities and geographies, as these devices are now starting to collect information from the vehicles. The departments of transportation, or state, local, and federal, now can capture that information and then have much better situational awareness of what's going on, with the vehicles and what they've encountered along the way and what they've seen, and how to better react and plan and provide information to other vehicles down the road.
All right, very good. Thank you for that. Carl, did you have any comment?
Certainly. I think, interestingly, Chip covered about 90% of what I was going to talk about, but I want to expand upon that a little bit. And thank you very much, Chip, because that was very coherent and really talks about what we within the Federal Highway Administration and the US DOT have been trying to do. And excuse me, Donna, thank you very much for inviting me to this panel and giving me the opportunity. So the Federal Highway Administration is working with other agencies within the Department of Transportation, with industry and academia on concepts called cooperative driving automation. And this is going to speak directly to what Chip just mentioned. This concept is predicated on data flows that can provide connected road users, and that could be pedestrians, bicyclists, vehicles, transit, and the infrastructure itself, with improved situational awareness to make more informed decisions that are anticipated to improve safety, efficiency, and resiliency. The data are structured around transportation systems, management and operations, TISMO use cases. These are use cases that your typical agency at the state and local level already deal with on a day-to-day basis. They look at things such as what happens with traffic flow around work zones. There's a traffic incident, road weather, special events, or just the daily congestion on your arterials and highways. We believe that infrastructure will play a key role in assessing real-time data to develop actionable information and relaying that to the road users, to traffic signals and other active traffic control devices. For example, a connected road user could receive an updated map explaining where a work zone is, indicating if there's a lane closure. If so, where does the taper begin? Where does the taper end? If there are workers present, which could lead to a reduced speed limit. With the current system of temporary markings, cones, and barrels, those are readily understood by human drivers. Sometimes these work zones could be quite complex in layout, and an automated vehicle, based upon its high definition map and then its onboard sensors, may recognize the work zone but have difficulty negotiating it in an efficient manner. So by providing that information electronically to the vehicle, it can make a better informed decision on how to transit through there and on whether or not it needs to reduce speed. We've actually tested that at our facility, and we used both the roadside units, as Chip mentioned. We also used the cloud. Our version is that we need to have maybe V2V, vehicle-to-vehicle communications, and some limited vehicle-to-infrastructure using the direct V2I, V2X, vehicle-to-everything communications. In many cases where it's not time critical, it's not safety critical, we can use the cloud, we can use other technologies, wireless technologies, to provide this situational information in a geo-fenced area, thereby freeing up spectrum for safety critical devices, of safety critical information. So that's just one way in which infrastructure can leverage data flows to provide vehicles and other road users with enhanced information. Now, I'm going to segue a little bit. I didn't warn Donna that the answer to this first question could take the entire hour, but I do want to make sure that Michael has an opportunity to speak as well, because I'm really excited that one of our partners at the local level is here. So one of the things I saw just yesterday was from protocol.com. Protocol is a basically an e-newsletter, and they have what they call the brain trust, where they take specific questions on advanced technology to various people in industry and within the government. The question they had this last Tuesday was, what will be the biggest milestone or news from the autonomous vehicle industry in 2022? There were 8 respondents. I'm going to be really quick, but they talked about things such as simulation, about clean energy, about the commercial vehicle opportunities, who will be the early adopters of automation, about AI, security, and also system of systems. How does AI move forward to where it's a reality in our world? And I want to talk very quickly about one of the other projects we have called Voices. Voices is the virtual open innovation collaborative environment for safety. Voices is a development that we're working with DoD to create a virtual environment for testing of new concepts, new hardware, new communications protocols, to ensure that they all work seamlessly and they are integrated together. we're developing a minimally viable product through the government, but the intent is for this to be turned over to industry and for the public agencies to lead and to use the ability to quickly in simulation evaluate new concepts and technologies before having to put things on the real world will rapidly advance our understanding of how to make an automated future that's integrating the vehicles to the infrastructure and other road users safer, more reliable, more efficient, and more equitable for our nation's people. So we do have, you can just Google voices space FHWA, and it'll bring you up to our webpage. It'll bring you up to, we have a Confluence page, and we actually have a community of practice made up of vehicle manufacturers, of telecommunications industry, of academia, to help guide us in the development of this amazing virtual world that we want to use to help forward these technologies. And with that, Donna, let me give it back to you before I go on with all the other great things that they're doing.
Very exciting, Carl. Thank you so much. And yes, Mike Sherwood, we'd love to have your thoughts on this. He's doing some real world practice in the city of Las Vegas. Oh, Mike, you're on mute.
I just saw that. Thank you, Donna, and thank you for letting me be here today. You know, Carl and Chip have done an excellent job. It covered about the whole gamut. The only things I would kind of include in that, we've talked a lot about practice and where we're going. I think a lot of things need to be discussed around cybersecurity and safety, and then just the exchange of data, how much data we're going to have and who will have access to that data. But I think it all relies back to, it all comes around to having the proper infrastructure in place for these systems really to be effective and to be safe.
Very good. Thank you. Excellent points for consideration. Thank you, gentlemen. You know, my next question, Mike, I think I want to start with you. How do you think the driver experience will evolve as different iterations of AVs are released in Las Vegas?
There's so many different types. When people say AV, they think of certain things. They think of a driverless vehicle without an individual. That is one form of AV. There are several forms here. Luckily for us, we've been testing autonomous vehicles with a safety driver in them. But they've been in operation here in Las Vegas for over a year and a half. And those are done by Aptiv, now Motional. But we also have new iterations, which I think the public would be interested in. These ones deal with, I call them half autonomous or half AV or AV 0.5. These are vehicles that a human driver still drives. Think of it as a rental vehicle. But when you're done with it, you drop it off, and then the vehicle is remotely driven back to a location by a human driver. So that there is different types of autonomous vehicles. We've also tested in Las Vegas an autonomous shuttle, which shuttled people up and down a street. And at the time it was a big deal in mixed flow traffic, meaning this vehicle operated alongside human drivers in a mixed environment. But I think you'll see lots of different iterations of AV technologies, everything to what we think of in the movies, where you're sitting there having your cup of coffee as your vehicle's driving you to work, to your vehicle once you're at work, going off and doing Uber and Lyft type rides and coming back to pick you up at the end of the day. You know, there's a wide variety, I think, of autonomous vehicle opportunities. I think what you'll physically see in a city like Las Vegas and most larger cities is a scaled down version over the next several years, where you might see loops that are pre-designed or pre-negotiated area where it's just in a circle. Think of it that way, of an autonomous vehicle. And that's something we're doing in our medical district, where we're going to launch in the next couple of years, just a call it people mover or a pedestrian access system that'll allow you to go from hospital to doctor, all within a confined district area. So I think you'll see some of those and become more popular, especially here in Las Vegas, where we're trying to move lots of people back and forth. You obviously know about our Boring Company project. We have vehicles underground now that are going to be autonomous at some point. So you're going to see just a large mix of vehicle modes. But please don't forget that autonomy also goes into smaller devices as well, where you might see I don't want to call them autonomous scooters yet, but there's all types of different types of transportation modes outside of a standard four vehicle or four tired vehicle that we're used to. So it's exciting. Just like Carl, I could go on for an hour just about what you might see. And we haven't really even covered anything that goes in the air as well. And those systems are also being demonstrated already. We've had some test flights of those in the vicinity. And so there's just so many different opportunities for autonomous vehicle technology to really impact our lives in positive ways, as long as we do it with the right infrastructure and safety in mind.
Wow, that's very exciting, Mike. Another good reason to go to Las Vegas. So very exciting. Thank you for sharing that. I can see why they call you a disruptor. Are there any further comments from the panel? Would anybody like to add to that? How these different iterations of AVs will come?
I'll make a comment. I'll tee Mike back up again here a little bit. I think Mike's done a lot of work with the OEMs directly. I know he's had partnerships with with BMW and Audi at different times. Either related to CES or other events that they've done. And I know they've worked extensively on, going back to my comments around RSUs and deploying of those devices. So I think it'd be great to hear a little more from Mike in terms of A, some of those partnerships, and B, what they've actually deployed in terms of RSUs in and around the city.
All right, very good. Carl, any thoughts?
Well, I wasn't sure if Michael was going to respond to Chip's question first.
Oh, sorry. I'm so sorry. Go ahead, Mike.
I surely can. I surely can. I can go into a little deeper dive about some of the technology that's embedded in the streets already, from a consortium of different technology companies, from Qualcomm to Samsung and to Siemens, and a bunch of different companies that have different types of we'll call V2X infrastructure components. We use different technologies here, DSRC, direct short range communication, that kind of provides to some vendors a communication with our signal. So it tells the signal basically what its status is at the time, red or green. So one-way communication, I think that was what Chip mentioned. A lot of the technologies we use right now are one-way, not because we can't do two-way, but more as we work through the safety issues of how that technology works. We also use some limited 5G components. It's basically the same thing as DSRC, just on a different frequency spectrum that allows us to communicate to vehicles and provide them different types of information. Currently, within the city limits, we have about 75 intersections that are enabled with some type of either DSRC or a different variation of communications to vehicles. We've had lots of partnerships. We continue to have partnerships with the companies that are here. As Carl talked about, simulations are excellent, and the virtual world, definitely you can do a lot with that to test and get things kind of worked out from a technology perspective, but nothing beats putting it into the field and actually see it working, where you actually can be in the vehicle and you see the status of a light pop up. It's truly an exciting moment. I know for some it won't sound exciting, but it is truly an exciting moment to be in a vehicle and see that it has that information populate within it. It's amazing then to sit back and look at, from a dashboard perspective, all these intersections and all the data that's being sent out to the vehicles, and the way the vehicles are able to use that information to adjust their ride, to adjust speed. Imagine, it won't be that long or that far off where, because of this signal infrastructure communications, that you may not hit a red light. You might be able to move the traffic out of flow that allows, it may not be the speed you want to go, but it would be an optimum speed that would allow you to freely egress along a road segment and get there quicker based on using the technology. There's lots of different, we've learned a lot. One of the biggest challenges, and I'll throw some challenges out there, I'm sure Carl and Chip will be able to help in this regard as well, is that there's so many different technologies, and it's getting the vehicle companies to come up with a standard. There is no one standard today. Some vehicle companies go completely on their own, but would like access to sensors such as air quality, micro weather is something we've been looking at, having weather street by block by block. And that can be important. Obviously, if you're driving, you don't want weather for an entire city region. You need more if you're going to adjust speed and correct for safety issues towards that Vision Zero methodology. You really need to have it available in a micro format. So there's just so much going on. I think that the biggest challenge over the next several years is just going to be coming to a standard that everybody can adopt and embrace. And I think that standard is going to be a mix. It's going to be a mix of government providing services and infrastructure and broad data sets. It's also going to be the vendors or the operators of vehicles, the manufacturers, in their regard of building their own systems. And it's going to be this overlay. And I keep going back to, I know it's going to make Chip happy, infrastructure. You're going to have, we have one of the largest private 5G networks that a city operates in CBRS in our community today that we've been building out, that we use for sensors and for vehicle communications. But you're also going to need fiber infrastructure assets. You're going to need commercial carrier cellular. You're going to use satellite communications. There's a layer of communications that will be necessary for all this technology to work, and not just to work efficiently, but the main, back to Carl's, one of his major points is safety. You're going to need to distinguish how and what data is used for what purpose. And so it's going to become it's an exciting time. I wish I was 20 and could just be entering the field. But I hope, that did justice a little bit to what, Chip wanted, a little bit more detail on what's going on. It is truly amazing to work with these car companies. And I really don't call car companies anymore. I consider them more software integrators now. They just happen to make some hardware along with it. But more and more of what they're doing in vehicles today is really application based. And it's going to really be impactful. And I think the other big impactful technology is we've been using a lot of AI now in its early stages, but allowing AI to control a signalized intersection all on its own based on historic data, analyzing historic information, analyzing real-time information, and then going ahead and changing light timing based on all the data that it has available, and to see if it really can not only predict, but increase efficiency within a metropolitan area. Lots of technology there, lots of fun things to talk about.
You
Yeah,
sound
let me
like
build
you're
on a
having
couple of
fun.
things. Yeah, Don, let me build on a couple of things that Mike
right
talked
ahead.
about. Yeah. So I just want to give everyone kind of appreciation of really the volume of data that we're talking about. So, we from Lumen have been working, with a number of the OEMs in their kind of test cars and test track type setups. And these are specially designed vehicles where they're capturing all of the LiDAR images and storing that and being able to take that back and be able to do hard scale data analytics and be able to program these vehicles. And to give appreciation in some of the just even the technology challenges that we're talking about. These vehicles are basically designed with, I call them suitcase size storage arrays that sit in the back. And these vehicles go around for just less than an hour worth of driving. They're generating terabytes of data, and so the historical way that they've done this is they had a plug-in suitcase style device that sat in the back of the car, and they would sit there and run it around for an hour or two, and then pull this suitcase out, put it in a case and mail it off to the manufacturer to sit there and capture all the data. They plug in a new one and drive it around. And so we're working with these companies just even to try to figure out, can we create smart depots where they take these test cars to, and either wirelessly or wired as they're recharging, try to download these terabytes and terabytes of data and get them transmitted out to these car companies to do the detailed analytics. So that gives you just an appreciation of the amount of data and information, and to Mike's point, the AI that has to go on inside of these vehicles. It's pretty significant. So Carl, probably have more comments on that as well.
I do, Donna. This is really exciting. This is almost like being in a three-way ping pong game. That ball is moving so fast and back and forth. First, I want to talk a little bit about what Michael said. Chip, I want to go right back to what you just mentioned.
Yeah.
Yeah, I am certainly excited, like you said, about how we can make the driving experience so much better for our human drivers, or for when they become passengers, and make it safer. So with regard to traffic signal lights and advancing that, we've been actually working with automobile manufacturers through a program that started way back in the dark ages when I still had dark hair, on vehicle to infrastructure safety. And we were looking at red light violation warnings. At the same time, my office was looking at something called glide path. How could we use the signal phase and timing information from the traffic signal light for a vehicle to moderate its speed and either approach the traffic light in a much more environmentally and fuel economically of time? It might not need to stop, but if it did, it could then accelerate away in an efficient manner, saving fuel, reducing emissions. And what we found was in a heavily signalized arterial, you could save 10 to 15% of fuel by using such an application. We worked then with the automobile manufacturers on this, and we're going to be demonstrating, or they're going to be demonstrating, because this is really the OEMs, the original equipment manufacturers, what we call TOSCO, traffic optimization and signalized corridors. They will have a string of vehicles from 4 different manufacturers that will be traveling together on a road in Houston at a high-speed arterial with signals. They will receive the information using the infrastructure that Michael and Chip have discussed, to give them information on the upcoming signal and the one after. And they can moderate their speed as a group to either eliminate the stop altogether or to approach it in a very economical manner. What's really neat is when it goes green, if they did have to stop, they will launch simultaneously, thereby improving the throughput, and they will accelerate in a fuel efficient manner back up to speed. So what you do is you significantly reduce the number of stops. And when you do have a stop, the idling time, you eliminate unnecessary accelerations to stop or to go. We want to see how that works. We've done it on test tracks. We've done it in simulation. But as Michael says, the rubber really hits the road when you put it out there in live traffic. So this will be in live traffic on a very heavily traveled arterial just north of Houston Airport. So we're excited about that coming up early in 2022 to see what the results of that are. And then going back, oh shoot, now Chip, I'm sitting here drawing a blank on what I wanted to address for you.
Data?
Data.
About data.
I think you need to come out to our facility and see how our program, we do the same thing. We have vehicles. We don't build vehicles, but we need them to test our concepts. And so they're out driving and they're collecting all that same data. They're collecting all of the basic safety messages that are transmitted by other vehicles, signal phase and timing information, anything coming from the cloud that we're sending them. And then also, of course, their LiDAR and other sensors. We have radar, cameras, video. You want to talk about data hogs, the video cameras, and then the LiDAR point clouds. We still today do take the device out and we plug it into a computer in the lab. When we do testing offsite, we take a temporary unit and then we use the I2 to transmit that data to the lab. So it's not in real time, but it's in near real time. We can download those data, look at them, and our software engineers can actually start modifying the software that we're using in the vehicles right then, so we can run another test maybe that afternoon or the next day to see if we've resolved any issues. What we are looking towards is the use of 5G to do this wirelessly. The very high bandwidth and the streamlined protocols of 5G may allow us to transmit these terabytes of data either as they're being collected or right after the run back to our lab. And so those are some of the things we're looking at. We are so excited about where the telecom industry is going in developing these technologies to allow us to do so. Who knows, maybe we will not need dedicated short-range communications anymore, because maybe everything will be going either on unlicensed spectrum using 5G, or maybe even on licensed spectrum using cellular vehicle to everything communications. So we're not selecting the technology. We are encouraging the automotive manufacturers, an industry, the telecom industry, to settle on how that technology will work. But while we're technology neutral, we're not technology agnostic. It has to improve safety. It has to be shown to be workable. And we want to make sure that safety is not something that the vehicle owner has to pay for. Other things they might have to pay for, but for safety, safety has to be ubiquitous, interoperable, and free. That's kind of our standing point in the US DOT. And as I think Michael also mentioned, it's this coming together of telecoms, computers on chip, the inexpensive memory and sensors, advancement in sensor technology that can be fused to allow the vehicle to make good decisions. And now our ability to send it even more data, rich data that allow it to have better situational awareness. We wouldn't be they've been looking at automated vehicles since 1936, but it never had all of those industries advanced to a point where we can actually start to realize it. So really excited about that, about the development of AI. And like I said, you're right, Michael, we should be 20 or Chip, whichever one of you said this, we should be 20 and just starting our careers.
Donna, I wish I was still 20 for a number of reasons. But yeah, I'll agree with Michael on that one as well.
Wow, that question took on a life of its own. That was a fantastic display of knowledge and insight. So thank you, gentlemen. Very excited. I do want to say, Carl, I loved your no pun intended, when the rubber hits the road. Just anyway, actually, we talked a lot about 5G and vehicle to vehicle. I'm not even sure if the next question, if we've completely saturated the question here. What are other technologies in development in which vehicles will communicate with each other and the environment, alluding to 5G, V2V, vehicle to infrastructure? Do you think we have anything more to say on that, gentlemen?
I'll build upon some things that both Carl and Michael talked about, and some of the things that we've been doing a lot of work around is CBRS, which is basically unlicensed spectrum that is leveraging cellular based technologies. And so we see a lot of uptake in a combination of both licensed and unlicensed spectrum type use cases out there in that space, and see a lot of promise in CBRS, again, not just for vehicle and autonomous vehicle communication, but just in general. When we talk about the broader discussion around IoT, the ability for jurisdictions, for enterprises to come in and spin up cellular based networks that they own and manage, leveraging either generally available spectrum or lightly licensed spectrum in those spaces, and be able to in essence set up their own private networks. And so many of them have done that using more traditional, say, Wi-Fi and other technologies, which doesn't have the power and the reach of the cellular technologies, and being able to leverage those technologies across a broad range of use cases. And so when we look at, and I know Michael's been looking at these use cases as well for using CBRS, it's not just vehicles. We talk a lot about rural broadband or disadvantaged broadband connectivity for folks. A lot of use cases that we see coming out using some of those unlicensed or lightly licensed type spectrums.
Donna, if I could.
Certainly.
So I really can't speak upon what new technology has been developed. It's outside of what I do. But what I would talk about, I think it was mentioned earlier, is the need for standards. SAE has actually developed a cooperative driving automation committee to take a look at this. And of course, we've been working with SAE for decades on developing the standards for vehicle to infrastructure and vehicle to vehicle communications. So there is a strong body of standards already existing, but many people in IoT and telecom may not really be aware of it. That's why we're kind of excited about voices, because what we're hoping is that through this virtual environment, a collaborative environment, they become more aware of what we're doing, and they can look at the interoperability issues. Because without good standards, we can't talk. It's sort of like learning a language. The SAE standard J2735 describes the message sets that we use to communicate today between vehicles and the infrastructure, and we need to build on that. As we move into the future, there are opportunities, there are commercial business opportunities within this field, but there needs to be interoperability. There needs to be, and we would prefer that it be ubiquitous and interoperable across all vehicle makes and manufacturers, across all the infrastructure components, because that's what will allow these concepts to work. That's what will improve safety, is this idea of having these standards. So personally, you can use smoke signals for all I care, as long as they're standardized and the vehicles understand them. The other thing I really wanted to point out is, I know there's been, and I'll talk about the elephant in the room, the FCC's ruling on the 5.9 gigahertz and some other directions. So we're kind of struggling right now to understand what that connectivity will be. So that's a challenge to the telecommunications industries. Help us pass this hurdle. Michael's put out roadside units, broadcasting DSRC. We're going to have a limited lifetime on that. So the other thing we need is something that will be forwardly compatible. There was no way any single technology will be used forever. We're always going to be moving to the next best technology, but we need to do so in a way, and that's the excitement about voices, is to be able to look at it and see how can we continue to support what's there, because when Michael puts something out, he wants it out there for a while. Infrastructure is expensive, and the taxpayers don't like to see their money wasted. So the infrastructure, the road network, you build a road, you're building it for 100 years. Now, granted, a traffic signal controller might only last a decade or two, but we're not used to the idea of changing things out every 3 years. I don't need the most recent iPhone at my intersection. I need something that'll be there for a while to be able to recoup that investment. So that's a challenge to the telecommunications industry and the developers of those components. But at the same time, we also want to be thinking forward. We want to be thinking about how new technologies, new opportunities will really continue, because we would like to see safety reach a point where there are 0 fatalities on our nation's road. We have a long way to go. Your group is one of the groups that can help us spread that news and try to get to a vision 0, where everything is revolved around how do we design the system so that when there is a mistake, it doesn't result in a fatality.
Very
Carl,
serious.
Do you have any idea of what the percentage of intersections are in the country that are actually connected? Because it seems like, most of, still a large, very large percentage, right? Those are
Right.
kind of standalone traffic control signals that don't even, talk to the signal down the block. Do you have an idea of kind of the uplift that's needed to even get, a decent percentage of the traffic, intersections in the country connected?
I might defer that to Michael, but I would say that most of our major cities, the signals are at least connected back to the traffic management system. All right.
Yep.
So the opportunity is there. But the real problem has been this chicken and this egg. Are there systems on the vehicles to talk to before you start investing on the infrastructure side? And the vehicles are saying, well, the infrastructure is not talking. Why should I put it in my vehicle? And that's why we really need to work together to come to an agreement on how we can best do this. Because under the new bipartisan infrastructure law, there are opportunities for us to start upgrading the infrastructure, but we need to have an agreement upon what to do, how to do that in a way that will protect the investment of Michael and the other cities and then on the states. We have 330,000 signalized intersections in the United States. We don't need 100% of them to be connected, because some of them are just out there on a rural road, or some of them are I'm sorry, when there's a 1-car backup, I'm really worried about improving the efficiency there right now. But in the future, we might want to do that. So this can grow organically over time in those areas where those kinds of use cases make the most sense. But I agree with you, it's a big, heavy lift. We don't really even have all of that information. And I know that our partners at the state and local level are very concerned about what's going to happen with the 5.9 gigahertz spectrum, and where do they go from here. They're hesitant to invest until there is some clarity on that situation. That's where we need the telecom industry to help us in working with the OEMs, the vehicle manufacturers.
So what I hear you saying is there's federal funds coming available to help the jurisdictions get there.
The federal aid program always provided for ITS, Intelligent Transportation System solutions. So there's always there, but there are so many needs. And I'm sorry, the funding is it's got to be spread over a lot of things. You need to look where the return on investment is. You need to look where the best investment is. We feel this is a really vital investment, but it needs to be proven to our partners, because they're the ones that are actually responsible for the spending, and for then maintaining and operating, and for training the staff. Let's not even overlook that huge expense of making sure that as you put in these new technologies, you have the staff to support them. I don't envy Michael his job. I'd much rather be sitting here talking about the great research we're doing. Michael has to figure out how to put it in the real world, and that's a tough job. So I'm gonna stop there.
No, really, thank you, Carl. As you're talking, you and Chip are bantering back and forth. I'm thinking about Michael and his real world challenges, and how he's getting through that and making the city of Las Vegas a great sort of beacon in the advancement of autonomous vehicles and traffic and everything. Michael, did you have anything you want to say? Or are you just going to accept graciously the kudos?
I appreciate you. I wish it was all about me. I mean, we have a great community here. We have great county resources. It's not just the city alone, but the county. And then we have our regional transportation organization that really helps with the centralization. One of the great things about Nevada is we do have a centralized communications infrastructure where city, county, and then this third agency manage and operate that. But to Carl's point, look, I'm like Carl, I love the technology. I love the new things. My bigger worry is, where's the workforce going to come from that's going to maintain and operate these? At some point, we're going to need to move towards a mix of private industry and government more working closely together, not where we just give a contract out. It's going to have to be more than that when you start having these shared systems intertwined. But the training and the education to operate this is going to be completely different than what it is today. So, our grandparents' intelligent infrastructure, our ITS network, is going to look nothing like the intelligent infrastructure in the next 5 to 10 years. Even in the last 10 years that I've been involved, it's drastically changed from where it wasn't really part of an IT department. It was kind of on its own. It was its own system, its own area. A lot of those engineers that worked on those systems, it was their pride and joy. Now they have IP addresses. They're actually little miniature computers everywhere. The technology needed and the depth of understanding is going to continually improve and increase rapidly. So there's going to be a real need to be able to have the right team on board to be able to move this forward, not just for our city, but for all cities. That will be one of the larger challenges. But like any new technology, adoption will come over time. People will become trained and educated, and these systems will roll out. They've been continually modifying and being improved over time, and we will continue down that way.
Obviously, this is so complex, and thank you, gentlemen, for bringing all of these points out. One of the next questions, and I know we're sort of running out of time, but I think, Carl, you've addressed it already in talking about standards. It's necessary to have standards. And I just wanted to ask, Mike, do you have any ideas on what standards were used in Las Vegas?
So we have a lot of standards that we follow for communications with vehicles and just protocols in general. One thing that makes us really unique in Las Vegas is that we do have something called CES, where a lot of companies come every year. And so while we try to standardize on certain technologies, when these companies come here on an annual basis and throughout the year, lots of trade shows, obviously the pandemic has put a little bit of a damper on that, but eventually we're going to get past that. And so we do have a variation of standards, which kind of makes it fun in a lot of ways for somebody like myself, who's a futurist and a technologist, not so fun for the people that write policy. And so there's a balance there. So we really don't follow, we kind of look at industry to help us dictate what standards, but you will see some of our signalized intersection poles that look more like a Christmas tree with a lot of ornaments on them, because there's many different technologies on there that are all, some work together, some do not. I think Carl pointed DSRC. We invested in that in the beginning, not because we thought it would be a technology for the future, but it was a technology for today. And so we did it where it wouldn't make sense for another city that wasn't really focused on the trade show component. The other component of why we do what we do in Las Vegas might come to a surprise as some, but it's also for economic development. Las Vegas is the capital of entertainment and fun, but we also realize that the future will require a lot of fun and a lot of entertainment. We don't want to get rid of that. You know, Las Vegas is synonymous with that, but we also want to be seen as an area where business wants to come and grow from a technology perspective, that we do have opportunity here, that there are great amenities here that bring people here to this community. And I think, you know, to Carl and Chip, there's going to be those things that some of us may like to live in a town with that rural road that has still the stop sign. I don't even know what those look like that often anymore, but you know, the metal sign. There won't be any technology. There's no need for technology there. And some people will live there. Other people are going to want to live in a city that has the amenities. And I think that's where the investment will come. Over time, there will be the cities that have that infrastructure and the ones that don't. And residents will choose where they want to congregate, where they want to live. And so that's kind of the investment we're making, is not just from a perspective of helping our community more efficient and safer, but also building out that investment into the future. When I talk to a lot of elected officials, I kind of remind them, because technology is a hard thing. They don't see anything. It's software. You know, it's like, Mr. Sherwood, what does that thing do up on the pole up there? And I try to explain it. It's always difficult sometimes. The way I relate to a lot of people, do you want to live in a city that had an open sewer, that basically didn't have the underground infrastructure of what we consider a modern society? And most of the times they say, no, I want it to be underground. You want to have your water delivered with a bucket from a well down the street. The answer is no. I like my warm shower in the morning. So if you think of those type of modern infrastructure conveniences, you will then understand where we need to be in the infrastructure area for modernized vehicle or movement of people. Because I tend to always, that all these systems are always geared towards driving. They are not. And I think Carl, one of the first things he mentioned, pedestrian could use access. Pedestrian, we have an app that allows pedestrians to get DSRC information. There are people that can use that. And so there's a lot of different modes of transportation that rely on this infrastructure. So standards wise, back to the point, we're all over the map because we kind of have a unique infrastructure for it. And we're using our investment to build a place for Las Vegas to be a center of excellence for the testing of these vehicles. Not every city wants to be known as that area, and is going to probably wait for standards to mature. And so we'll see. I have my favorites going forward. I think cellular is going to be a huge, satellite and cellular communications are going to be huge. If you want to talk about from a high level platform standard, and people, please don't forget fiber. Fiber is necessary. It's needed. When you're doing road work, put in the conduit today, even if you don't have the fiber, build some of that infrastructure for the future, because no matter what aerial over the air technologies there are, you will always need, for the vast amount of data, some high speed, really rock solid, I'll use a technology term, but rock solid way of getting data from A to B.
That is an excellent takeaway. Very excellent takeaway. Mike, yes. Let me, I did have sort of a tongue-in-cheek question that I wanted to ask, which is, and I know I spoke to Carl a little bit about this, so I'll ask Carl to comment first, but I want everyone's comment. And again, it's a tongue-in-cheek question, but are we being completely realistic about autonomous vehicles, or should we all just hire a chauffeur?
Okay, so, we're recording this webinar. And of course, I've been introduced as coming from the Federal Highway Administration, but the agency is not going to take a position on that. So what I'm going to tell you will be from me. But I also realize that because I was introduced from the Federal Highway Administration, people will still think it's a governmental position. So please understand it is not. Industry, when I talk about industry, the automobile manufacturers, they're tier 1 suppliers, and new players in the automated driving systems arena are really working tremendously hard and investing a lot in developing automated systems. But as Michael said, there's a lot of different flavors of automation. A couple of things that are sort of interesting is that one of the most difficult areas to operate in a central business district of a city, maybe part of the place that sees high levels of automation first. While it's very busy, it usually has slower speed limits, it has a well-defined environment, and there's a wealth of opportunity to provide data flows, as Michael pointed out. And that allows for safer operations. The vehicle can operate at a speed that allows it time to actually make sense of all of its surroundings, and those data flows will help. And that would be, as Michael mentioned, maybe Robo Taxis, that Uber and Lyft vehicles that don't have a driver in them, or shuttles that are on a fixed route. There are a lot of different ways, and we do think that this might be something that'll be an early adoption for automation. Conversely, on our interstates, it could be freight. The nation is already facing a shortage of long-haul drivers, and that's only going to get worse. And we see all the problems with our supply chain right now.
Yes.
So imagine if a vehicle can operate on the interstate, it might not be able to operate on the local roads. So the driver would still be necessary. But if the vehicle takes the brunt of the long distance driving, that means when they get to the point where the vehicle needs to off-ramp, the driver is fresh and alert. You could see a time of just a safer operations because the driver comes off that highway, but he's on a local road. And so he's already adapted to that slower speed. He hasn't been driving for 4 or 5 hours at 70 miles an hour. He's there when it's ready to off ramp. So we think that would improve safety. And not only that, the vehicle won't become tired or distracted during that drive. And so those are things that I know that vehicle manufacturers and several startup companies looking at automation for trucks, commercial motor vehicles, are really advancing that. So those are two very different approaches, and they're worlds apart. And so what we would see is that potentially that would be sort of the first rollouts. I see the most challenging areas being the suburbs. A lot of times slightly higher speeds, you're not in a grid, and things happen. People walk out, kids are playing, there's bicyclists. Those may be the last areas to actually become. And then, of course, as Michael pointed out, some of the rural areas, the very rural areas, where there might be limited coverage. The vehicle will really have to be robust to operate on a gravel road in Michigan. I'm sorry. It's really hard for us to put lane lines down on a gravel road. So those vehicles are going to have to really be robust because human drivers are actually pretty amazing at what they can do. And to be able to replicate that with an automated, vehicle, the AI that's on board, especially in a rural area with perhaps no connectivity, is a very heavy lift. And so I think that as long as we don't think that tomorrow we're going to be able to get in a vehicle in our garage and it'll drive us to work, and at the end of the day, it'll drive us home. Or maybe it'll leave work and go run errands for us until we're ready to leave work. We can't think that's going to happen tomorrow or in the next few years. but where there are opportunities where automation can be used in the niche areas, grow from those to greater and greater operating design domains, areas where they're capable, and greatly improve safety by not becoming tired, distracted, or operating drunk. I haven't yet seen a drunk AI. It could happen, but we haven't seen them yet. So when I say, I just want to preface this by saying we need to check what our enthusiasm is, look at where the technology is, look at the challenges, but embrace it and be ready to enjoy that future ride.
Sounds
Yeah, and to
good.
build upon what Carl said, there are a couple startups out there that are, on the long haul side developing, truck depots. And so basically the trucks would run autonomously over the long haul run, pull into the depot, a driver would be stationed to that depot and would take it the last, X number of miles to, pull up at the store or wherever that they were pulling into. And so, those are the steps where, the adoption and frankly, the comfort level of the general public and, the highway administration and US DOT and state DOTs start feeling more comfortable with, those things being completely, non driver assisted.
Very good. And Mike, you've got a little bit of that going on already, though. That's what I heard you say earlier.
We do have a little bit, but obviously the long haul trucking, which is a great scenario, that's going to be huge, and that's going to be more on the federal level than it will be the state and local level. But the technology might roughly be very much similar, and it will be cross compatible at some point, if that's going to come to fruition. So, and I agree with Carl and both. I think that's the one that you're going to see more of the autonomous, the trucking industry and moving of freight, will be more of a, even in the drone space, even in the vehicle space, that moving of goods and materials will most likely be more of what we see go full autonomous before we do the vehicles we get into. And to Carl's point, there is no AI like the human brain. And so, we haven't replaced it yet, although the human brain can make errors at times, as Carl's noted, especially if it's induced with certain chemicals. But for the most part, the brain is still not replaceable by AI just yet.
Yes, I believe Carl actually gave me at one point how many 1-point-something million miles per fatality, driven miles. I don't know if you remember that, Carl, or not.
It's over 100 million vehicle miles traveled. The scary thing is I don't know if everyone really realizes how much we drive. So we've got now, pre-pandemic, 3.3 trillion vehicle miles traveled in 2019. If anybody wants to put that into another term, that's half a light year. As Americans, we drive half a light year in a year. Now, if we could stitch those all together, we could get to, Alpha Centauri in just a couple of years. That's how much we drive. And the fatality rate, the fatalities is terrible. Loss of one life is too many. But when you look at that, you say, that's a really great safety record, but it's still, way too many people. And so the exciting thing about automation is how it can help us start on the downward trend of fatalities again and get to that point where truly everybody arrives home or at work or at a party, wherever they're going safely. That's our vision. All the rest of it, the efficiency is another important thing to federal highway. The efficiency of the roadway system is actually one of our mandates, but that comes second to ensuring that first the people are safe. And then we're looking at all of the other challenges of equity. How do we make this future system equitable for all travelers? How do we help those who have been on the margins for so many years, those that are challenged to be able to, and they're no longer independent, whether you get old enough to where you have to turn your keys in or whether you've never been able to drive? How can we bring them into, all of the opportunity of American society? So yeah, automation is just what it might do for us as a people is just really is mind-boggling. It will really change how society operates, but we want to make sure it does it in a safe way. And I got so many other things I'd like to talk to you about: our truck platooning demonstration, about our work with the Maritime Administration on port drayage being automated. So there are a lot of exciting things going on that will really fundamentally change how we operate the transportation system. And some of that will be in the background. You won't notice it. As Chip mentioned, the truck that drives to a depot and then the driver gets in it, you may never notice that. But it will change how our society operates and our logistics train. So all really exciting stuff.
Very
Carl,
much.
can I ask you another question? I'm sorry, Donna, I want to take
No,
over
go
your-
ahead,
your-
Chip. Go right
So one of
ahead.
the other use cases that we worked with a city in the, we'll call it in the snow belt or the Rockies, was, around, smart roads, and meaning, actually putting sensors on the pavement to understand, freezing conditions and all of that. And, they use that to kind of direct snow plows and things like that. And obviously, road conditions are going to be a critical kind of limiting factor for autonomous vehicles and trying to, account for, non-standard driving conditions. So I'd love to hear more from Carl or from Michael in terms of, any other initiatives that are going on, maybe at a DOT level or at a state and local level around kind of road condition monitoring and some of those things, because that all kind of falls into the same general bucket.
Well, I'll go really quickly because Michael may have more insight in this. Why we're excited about cooperative driving automation is it's about data flows, not just for the infrastructure of the vehicles, but between vehicles and from the vehicles back to the infrastructure. We can use vehicle sensor technology to monitor the condition of the road. There's a company out there right now that works with one of the automotive companies that constantly measures the frictional coefficient of the road and the road roughness and pushes it back up to the cloud. Now, if everyone did that, we would have a minute-by-minute map of frictional conditions on the nation's roads that could be then geofenced and provided to every vehicle driving. Or the road roughness, which would go back to the agency to make decisions about just-in-time maintenance. Where does it need to be repaved or resurfaced? Those are what go back to your initial question on data flow. And it also goes to a question on the chat from Ryan Crandall, which is data security. No matter how we do this, it really is going to require that we have really good data flows, but that they're also secure, they're trusted, they're trustworthy data that we can act on. Because I would hate for somebody to hack into that friction data and make it seem like a road is in great condition when you have black ice. I mean, so you're sitting there driving at highway speed and you hit the black ice. So data security is going to be a key thing, well outside of my area. But there are other agencies that are working on cybersecurity, and I'm hopeful that that Ryan and others that have that question are looking at that issue and those other agencies. But I don't know that we need to put them in the road everywhere. There may be limited areas, Chip, where it's important enough we want to know, like on bridges in certain areas. But, with as many lane miles as we have in the United States, trying to put sensors in every lane mile, I'm sorry, even the bipartisan infrastructure law doesn't have enough money for that. But Michael might be able to talk about how they might be doing it in the cities.
Well, Carl, I don't have a lot to say there. Cybersecurity is a big deal. I mean, it's becoming, it's a whole new realm for where local leaders have to look at investing where they haven't had to invest capital before. They're used to investing for cybersecurity and data security on the operational business networks of an organization. It's a whole new thing to have to invest in now, this whole new area. Well, we've always had some security in ITS systems or traffic systems. They've never been connected to the internet in the ways that they're being connected today. They weren't connected to multiple vendors and multiple systems like they are being connected today. So, it's a work in progress. I can say Ours is completely segregated as one way of trying to do that. But again, you need to be able to not just be segregated, but be interoperable, because people want the data, and you got to share it out to a lot of different agencies and organizations. We've been working with several commercial companies that want our signalized data so that they can use it for their vehicle fleet, whether it's human or whether it's in the future going to be autonomous. They want that information. So how do you work on that to be able to come up with the standards? And it's a work in progress. I will leave it there, is that as a work in progress, it needs to be high on the list as we go forward. I think we've seen over the last several years the need for cybersecurity, the need to ensure our critical infrastructure is well protected. But it is going to be a learning process, and I think people do well at learning. Look, when the intersection goes out and it goes flashing red, human drivers know what to do. Autonomous vehicles will know what to do as well. And we're going to need to get through some of the bumps in the road. And cybersecurity, we're going to have some bumps. And so we'll see. And then, back to the other point is there are going to be a lot of sensors out there. How we're going to manage them, and that's a whole conversation on its own. The viability of them, the operation and maintenance of them. Are we going to go throwaway sensors, or are we going to go with sensors that can be updated with software? Very hard to know right now. Right now we use a mix. But again, we're kind of in that business because we want to be in there. Is it mature enough for a city to go ahead and make large citywide investments? I don't know yet. I don't think we're there yet. I think we're getting towards that, but the technology still has a long way to go.
Donna, if I could just do a real quick advertisement.
Absolutely.
From what Michael has just said in the question, from what you've heard, hopefully everyone participating today realizes these are not issues for one agency or one department or even one industry. This is really issues that are going to encompass all of these industries, across, many people that don't even realize they're part of this are really are vital to us to understand. Cybersecurity, AI, data flow, sensors, sensor fusion, all of that are all key things. And like I said, it's spread over a lot of different silos right now. And so we really do need to understand how to come together and work together.
Yes, thank you for summing that up, Carl. I appreciate that. It's very daunting to someone like myself anyway. I do want to say that give everyone an opportunity to have a key takeaway. So as we're concluding, maybe we could start, Carl, with you. If you have a key takeaway from this conversation that you'd like to tell industry as well as other government, what you'd like them to think about this topic.
Well, actually, I was saying a very personal nature. I got to get out to Las Vegas again and just spend a little time with Michael and see what is going on. We sit
road trip.
We sit, yeah. I hope we haven't been on travel for a long time. We're working at the federal level on certain things, and we need to really understand what people like Michael are experiencing, but not just our partners at state and local, but CHIP and all of the others within the industry, what your challenges are. And so that's why we really do try to develop communities of practice and collaboratives where we can bring people in to share what they're learning and to help direct us. We want to be doing the right research at the right time to help in this area. So it's challenging, but it's a lot of fun. It's why I still like to come to work. Otherwise, I could be long retired. But I intend to continue to do this because, as Michael and Chip have mentioned, this is just a really exciting time to be in transportation, and it is something that's going to touch all of our lives, and hopefully in a very, very positive way. But to do that, we need to work together to make that it's secure, the data are reliable, and that we can provide that sort of benefit to the nation.
Thank you. Well said, Carl. Michael, last thoughts?
Sure. My biggest takeaway will just be very simple, is for any organization, whether it be a private business or a city municipality, start today. Go out and find everybody, find that intersection, excuse me, that you have in your city, maybe in a low risk area, and start working with the private industry and start getting a feel for what it's going to take. Doesn't mean you have to put it out in your entire city or your entire footprint, but I think there's a lot of discussions to be had around cybersecurity, around maintenance, operation, investment. Being able to start bringing your elected leaders on board, showing them is always a great way, not just pointing to a newspaper article or something else, but having it in your jurisdiction, starting to understand what's happening in the industry, and then being able to establish relationships. We wouldn't be where we are today in our journey if we didn't have the private partner relationships, if we didn't have the federal government relationships, didn't have the state relationships, and certainly without our county and other municipal partners that make these things possible. It's not done by a person or by one entity. It's done by having great relationships with a lot of great people, and it takes time to build those. So to me, takeaway, start the journey, start your research, get a pilot up and running in your organization, and start reaching out to others to help you get to where you want to be.
Excellent, excellent advice. It takes a village to raise a AV. Chip, your final thoughts?
Sure. I'll give kind of recap on some of the things that Carl and Michael said. We are still early in this journey. I mean, we are using the baseball analogy, right? I think probably in the second inning, maybe in the third inning of this technology evolving. As I said earlier, while the vehicle manufacturers have had different combinations of some of these things, going back 15, maybe even 20 years, the technology is still relatively in its infancy, and the standards are still coming together and all of those things. But getting involved, so you're not too late if you're thinking, oh well, this technology is accelerated past me. It is absolutely not. It's still coming along and doing that, but the time to get engaged is now, and because it is going to take a consolidated effort across all of the government agencies, federal, state, local, private industry, a ton of different industry partnerships that need to come together, because this is, there's a lot of work to really make this work effectively.
Thank you very much. If I could just add some of the comments, Carl sent me a document last evening. I read through it, a couple of different points to bring out that I think are excellent takeaways as well. Is the Alex Rodriguez, co-founder of Embark Truck, says there won't be one singular achievement that defines the AV industry. It's about building layers of innovation over time versus focusing on one specific moonshot. And then Anthony Cook, who's a former chief counsel at the National Highway Safety Administration, said that the real value case for customers is safety enhancements, time returned to the driver, and operating stress eliminated. I thought that was pretty interesting comment. And then the CEO for Safe AI said that labor shortages, dangerous working conditions, and rampant inefficiencies have created huge demand for autonomy in off-road industries like agriculture, construction, and mining. With tightly controlled environments, repetitive work, and fewer regulatory hurdles, these industries are ripe for immediate disruption. So this is obviously a very exciting and evolving technology. Thank you, gentlemen, on behalf of ITPA for sharing your knowledgeable insights with us. And I'll turn the conversation back over to you, Pat.
Thank you, Donna. And just a round of applause to our speaker, co-chair, Ms. Donna Miller, who's done a tremendous job, her vision and leadership to bring this very important topic to our sponsors and our community at large. I'd also like to give a virtual round of applause to our panelists, Mr. Carl Anderson of the Federal Highway Commission, Mr. Michael Sherwood of the City of Las Vegas, and then also Mr. Chip Swisher of Lumen Technologies. Great job, interesting topic, and look to hear more about this topic in the future. So with that, I will once again give a special thank you to all of our sponsors for this season. We greatly appreciate your sponsorship. To our platinum sponsors, Abire Government Solutions, Comcast Government Services, Granite Government Solutions, Hughes Government and Defense Solutions, Lumen Technologies, and CommScope. To our gold sponsors, BT Federal, Crown Castle, MetTel, Sus Consulting, T-Mobile, Secure Federal Operations, and Verizon. To our silver sponsors, Equinix, GES, Turning Point, Pathway Partners, and Zscaler. And once again, our technology sponsor, Panoptis Intelligence. I'd also like to announce we have a few upcoming events, including the return of our annual in-person golf tournament in the month of October, date TBD. But first, a quick review of our February event, which we will have a data-driven focus with guest speaker Jamie Holcomb, who is the Chief Information Officer of the United States Patent and Trade Office. With that said, thank you all for your continued support of our local chapter and donating throughout the year. I hope you all will join us again and for our golf tournament, and look forward to meeting with you all in the future. Considering where we are with the current number of cases that have been communicated through the media, we're looking at rejoining a in-person series or revisiting in-person series in the spring. So more to follow. But thanks all, and thank you for attending.